What we're working on today is something called completing the square. And it's what we use to change a quadratic function from standard form to vertex form. Because if you remember when we learned about standard and vertex form is not all that useful. But with vertex form, it can tell you a lot about the function, about the parabola. So rather than trying to figure out all kinds of stuff about standard form, we just switch it into vertex form and then we already know. So this is going to be more algebra based than anything we've been doing. Who likes algebra? Yes? Good. So this is kind of an algebra skill that you need to learn. But the first thing, I just want to talk about this. We just did some factoring with perfect square trinomials. Here's how you can identify a perfect square trinomial. Here's how you factor it once you know that it's a perfect square trinomial. So this is going to be a shortcut for some factoring. A trinomial is a perfect square trinomial if the first and last terms are of the form a squared and b squared, which means they're perfect squares. So if you have something like x squared plus 6x plus 9. Is x squared a perfect square? Yeah. Is 9 a perfect square? Yeah. So that's maybe a perfect square trinomial. Let's put it here.
What do you mean by maybe?
Well, we didn't look at the second condition yet. So just having the first and last term as perfect squares is not enough. Here's the second condition. The middle term is 2 or negative 2 times the product of a and b. What? So if we go back to that one, x squared plus 6x plus 9, and we're saying the first terms are a squared and b squared. Here's a squared, here's b squared. Then what's a? If x squared is a squared, what's a?
1.
X squared is a squared.
It's 1, right?
It's not 1, it's x. It's the
Right.
square root of that. So the square root of the first term, and what's the square root of the last term?
So 9. X and 3.
X and 3 are the a and b. So if we do x times 3 times either 2 or negative 2, it should give us the middle term. Does that give you the middle term? X times 3 times 2, 6x. So that is a perfect square trinomial. That's important for this lesson, what we're doing, because what you're going to be doing is making perfect square trinomials. So what you have to remember is that if the first and last term are perfect squares, and the square root of the first term multiplied by the square root of the last term multiplied by 2 is equal to the middle term, then it's a perfect square trinomial. If you've determined that something is a perfect square trinomial, then it's really easy to factor. This shows you how to factor it. You just factor it by taking the square root of the first term, and then you take the sign from the second term, so positive or negative, and then you take the square root of the last term. So really easy to factor. If I gave you one like, let's see, I'll think up a good one. Here's an example, 49x squared plus 56x plus 16. Is that a perfect square trinomial? Yes, because the square root of the first term multiplied by the square root of the last term multiplied by 2 gives you 56. If you were just given that and told to factor it, it's not that easy to factor, right? But if you know that it's a perfect square trinomial, then all you have to do is the square root of the first term, which is going to be 7x. The sign from the second term, it's positive, and the square root of the last term. So 4, and then squared. It's a shortcut for factoring when you recognize something as a perfect square. What we want to do is take a quadratic function that's in standard form and change it into vertex form. That process is called completing the square. I have the steps here of how to do it, and I have an example. We're going to go through it step by step. And you're going to have to probably see a couple of examples before it really makes sense, but you'll figure it out. So the first step says factor out the coefficient of the first term from the first two terms. Usually when you're taking out a factor, you're looking at the greatest common factor. That's not what we're doing here. We're just factoring out the coefficient of the first term from the first two terms. So here's what that's going to look like. 6? The coefficient is what? Oh, you're going to have a 6 in your answer? Is that what you're saying?
Yes.
So the coefficient is 3. When we take out the 3, what's left in this term? X squared. And what's left in the second term? That's the 6 that you're talking about? 6? 6x, right? And then watch what I do. I leave a space, then close the bracket, and that plus 20 stays on the outside. You'll see in a second what the space is for. Step 2 is complete the square to make a perfect square trinomial by adding a 0 pair. Yeah, some of these, until you see it, the instruction might not quite make sense. But complete the square to make a perfect square trinomial. So this is what we were talking about before, perfect square trinomials. If I have x squared plus 6x, what do I need on the end of it to turn it into a perfect square trinomial? The number that's going to go in there is 9. Because you have to take, we're kind of working backwards from testing if something's a perfect square. We're making a perfect square. But if you take half of that first number and square it, you'll get the number that you need to add. Because that's kind of the backwards operations. Take half of the middle number, the second number, and square it. That'll give you the last number. So 6 divided by 2 is 3. 3 squared is 9. Now we have a perfect square trinomial. Okay, so one more time. Take that second term, divide it by 2, and square it. Now we can test, is it a perfect square trinomial? Well, the square root of x squared is x. Square root of 9 is 3. 3x times 2 is 6. So it is. The problem here, though, is that, can I just take an equation like that and add a 9 out of the blue? No, totally changes it, right?
You gotta have the same thing to the other side.
Same thing to the other side. Or the way I'm actually going to do it here is I added 9. I'm also going to subtract 9. Oops. That should be a subtraction this time. If I add 9, I want to subtract 9. Because then what did I do? Nothing, right? I added 9 and then I took it away. I really didn't do anything, so I didn't change the equation, but I did change the way that it looks, which is what I need to do, because I'm trying to change it from standard form to vertex form. And the only difference is the way that it looks is still the same equation. The third step says remove the extra term from the brackets. So the extra term is the -9 that I put in there. I need it as part of the equation, but I don't want it inside the brackets, because all I want inside those brackets is the perfect square trinomial. So we'll just take it out of there. X squared plus 6x plus 9. I'm going to close the bracket there. That -9 is going to come out, but look what happens to it.
That's where it's probably 27.
It's a -27.
So you brought it out and multiplied it by 3.
Right, when I brought it out, I multiplied it by 3 because the 3 in front says multiply everything that's in here. So to take that term out, you have to multiply it by the coefficient that's outside the brackets. The last step is factor the trinomial and simplify. But here's the great part about factoring the trinomial. What kind of trinomial is it? Perfect square. Super easy to factor. Take the square root of the first term, x. Take the sign from the second term, plus. Take the square root of the last term, 3. Put a squared on the outside. And then I want to simplify -27 plus 20. -7. Look at that equation. What's it look like?
That's scary. Oh, what the heck? Wait, where did you get the plug?
It's vertex form.
What?
Here's another example. This question is worded differently, but it's the same thing. It says algebraically determine the coordinates of the vertex of y equals negative 2x squared plus 10x plus 7. I'm going to do that by putting it into vertex form. Once it's in vertex form, I know where the vertex is. So I'm going to start by factoring out that coefficient of negative 2, right? Y equals negative 2, and then open a bracket. This becomes x squared. And then I'm doing 10x divided by negative 2, which is negative 5x. I'll leave that space, and the plus 7 stays on the outside. That's the first step. So factor that negative 2 out of the first two terms. The next step is the part that's actually completing the square. Make that a perfect square trinomial by adding something to it.
25.
Is it 25? No, what is it? 6.25. Or 25 over 4. Right? It's half of 5 squared. We can call it 6.25. I would usually call it 25 over 4. Actually, I'm going to call it 25 over 4. So the way I got that was negative 5 divided by 2 squared. Negative 5 squared is 25. 2 squared is 4. That's where the 25 over 4 comes from.
6.25.
Yeah. So notice that I also subtracted 25 over 4. That's because we need that zero pair. We can add 0 whenever we want. And the 0 can look like anything you want, as long as it equals 0. But we can't just add any other number. So that's why we have the plus 25 over 4 and the negative 25 over 4. So now I'm going to take that extra term out of there. The negative 25 over 4 comes out. But don't forget it has to multiply by the negative 2 that's in front. So this is going to become plus 25 over 2 plus 7. That's 12.5, right? Then factor. The negative 2 is still there. When I factor this, square root of x squared is x. Take the negative from the 5x. And then the square root of 25 over 4, which is 5 over 2. Squared, don't forget to write that squared in there. And then I can add 25 over 2 and 7, which is 39 over 2. Or 19.5. The question asks, what are the coordinates of the vertex? What are the coordinates of the vertex?
Negative 5 over 2.
Positive 5 over 2
Yeah.
and 39 over 2. That's the vertex.